So we're going to go now to QGIS, okay, and we're going to try to do some work. We're going to go slowly and introducing the processing framework from the very beginning. We're going to do some small exercises. The data folder that you have, it has subfolders with different names for each one of the lessons, the small lessons that we're going to do. And what we're going to see is the main elements of processing and start exploring some of the algorithms, right? So if you have processing installed, you should have a folder called, a menu entry called processing in here, right? And that's everything you need. You see there are no icons, there's nothing else, although there's a lot of power in processing and it does a lot of things. You just have one single entry point for all that in processing there, so there are no extra things that you can use. And that's our main menu, and actually from that main menu, the element that we're going to use most of the time is the toolbox, which is like the central graphical element of processing, right? Everyone has that installed, right? Processing there, cool. Before we start doing that, I'm going to show you how to update it, because you have QGIS version 2.2, right? And as I said, processing is a core plugin. That means that when there's a new version of QGIS, it also has the latest version of processing, right? So when there's a new version 2.3, they will have all the changes that we are currently doing on the processing code. But in the processing project, it's also an independent project. That means that we're releasing our own version. That means that if now I work with you, for instance, and I find something that doesn't work, I will go and fix it, right? But you don't have to wait for the next QGIS version, because we release versions of processing more often, right? And QGIS has a very nice thing, that is the plugin manager. I don't know if you have used it. If not, it would be interesting for you to see how it works. So QGIS is the basic QGIS with the core plugins. There are basically 4 or 5 core plugins. It's processing, the database manager, Atlas, and some other ones. So there's like, you know, the main plugins. But then there's a very large collection of plugins that people contribute, right? And maybe some of those plugins are going to be interesting for you if you do some specific things. Maybe you can develop your own plugins and add them, etc. And they are all managed through the plugin interface. I'm going to show you how to use that to download new plugins or to update the plugins that you have. That means that if, as I said, we find some problem in here and I fix it and I release a new version next week, and you want to have those changes in your processing, you don't have to wait until the new QGIS is ready. You can download this new version of processing, right? So in the menu that says plugin, you have the manage and install plugins. Then you have the Python console. We're going to work with the Python console later. We'll see that. So you click manage and install plugins. You must have an internet connection, of course, right? And you get to something like that. Might be slower or faster depending on your internet connection. Everyone get to that one. Feel free to stop me, because I tend to go too fast, right? So if there's something that I go too fast or you don't understand, just say, hey, Victor, say that again, right? Because I know this pretty well and I tend to go fast. I know it. Okay, so if you click on install, you're going to see the plugins that you have installed, right? You know, I have some plugins that you might not have, plugins that, this is what I do for a living in my work, right? But if you search in here, you have processing, should be installed. Even if it's installed, you can turn them off. You can just uncheck that, so they're installed, but they don't appear on your menu, right? And then you should see like not install, new, and all the other stuff in there, right? And the thing is that when there's some plugins that there's a newer version on the repository, right? In the plugin collection that is centralized by the QGIS project. If there's a new version, you're going to see it as a plugin that you can update, right? And then you can go and upgrade the plugin. In this case, I'm not going to see it because I'm running the latest version. If you go to settings, right? You can here check for updates on startup. That means that each time you start QGIS, it's going to look for new versions of your plugins. And if I release a new version of processing, it will say, hey, there's a new version of processing, right? Do you want to download it? Yes, no, and then you can download it. And it's as easy as that. You just download it, and okay, it downloads it, and you have a newer version, right? It's no problem here because we're going to do pretty basic things with processing. So you might have some bug fixes, but no more advanced things. Yeah. So let's go to the processing menu. You see, not that much. Doesn't seem that it's a tool that does so many things because we have very few items in that menu. And as I mentioned, our main one is the toolbox. The toolbox is basically a collection of all the algorithms that we're going to use, right? That's it. It's basically all the algorithms, and we can run them from there, and we can execute them. And this is what we're going to do now. So let's open the toolbox. Right. Everyone in here? Yeah. I don't know if in your case it might look differently. See down here, say advanced interface. You can turn this off and put it into simplified interface. That maybe by default is the one that you have. So what's the difference between the simplified and the advanced? The simplified interface, it's for people that you don't have to know what's going underneath, which software it's being called actually, and you just have all the list of stuff in here, all the geo-algorithms. You just haven't divided in groups. So let's say I want to do something for about hydrology. So I look here like the domain-specific hydrology, and I have my stuff in here, right? While if I use the advanced interface, I have all these providers. Remember what I told you that processing is a consumer of geo-algorithms. So it uses different algorithms from different places. One of them is last tools, right? I remember. I told you. But some of the ones that are like GWR, GRASS, or Toolbox, which is a software for image analysis. QGIS, that's algorithms that are actually implemented in QGIS. Saga, which is a German software that we are going to use a lot, for especially for raster analysis, most of the things. Okay, I can add new ones. I can add like the last tool provider in here. Okay, this is like the more complex thing. Like you actually see the software. That might sound a bit strange for using GRASS, Saga, or Feo. Okay, and the other one is simplified. But the names of the algorithms are the same. So actually, it's just different organization. So when I just find an algorithm, you can use whether the advanced or the simplified, whatever you prefer. And we're going to find the algorithms, right? Understood in here? Okay. As I said, it's a large collection of algorithms. Many of them, you see 158 coming from GRASS, 250 coming from Saga. In total, there are many, many of them. It's difficult to find them. But even when you know what you want, if you, let's say you want the famous Kriging, right? Even if you know that you're going to use it, whatever, it's difficult to find because it's a long list. But we have a search box, right? So you can, in this search box, you type whatever and it filters out, right? So if I want to find Kriging, I just type Kriging and it's in there, right? Okay, as you see, there are many different types of Kriging. It's not just Kriging, it's many different types, right? Okay, so we're going to use that. So in case when I say, let's go to that algorithm, what I'm going to do is type something in the filter box. It's going to filter the tree with all the algorithms, and then it would be easier to find the algorithm. Just double click on it and run it, right? Okay, so everyone has copied the data folder to your system. We're going to use the data. Okay. So let's do that. In the data sets, in each folder, there's a project. So we have to open is the project, and that project will open all the data we need. Sometimes, as in this first case, it's just going to be one layer. Some other cases, it's going to be several layers. I know most of you are familiar with QGIS, right? You know how to open a project, change the symbology, more or less. If there's any QGIS question, just feel free to ask me, right? Because the idea here is to teach you analysis. But if you don't know QGIS, that's not going to be very useful. So if you don't learn any analysis, but you end up knowing QGIS much better, we change the approach of the course, right? But feel free to ask me if there's something that you don't understand, right? Whatever it's QGIS, or if we're unzipping a file and you don't know how to do that. So whatever you don't understand, just stop it, right? Don't be shy. Okay, we're going to open a project from the list of all the projects that we have. It should be open, and then we go to wherever we put that. you should have something like that, right? All the list of folders, each one correspond to one of the lessons. I don't know if we're going to go through all the lessons, or maybe just a few of them. Then we will use some other data, as I said, data that Lean is going to provide, or data that you yourself can provide, right? So let's go to the first alg. The one called first alg is our first algorithm. We're going to execute our first algorithm. Right, so this is the project. It might complain because it was created a project with an older version. Don't worry about it, it's the same. So we have a very simple layer, right? It's just 2 polygons, and we're going to run our first algorithm. And I'm going to use that to explain you the main ideas about processing, right? So what we're going to do is to calculate a centroid. Right? The centroid is the center of gravity of the polygons. There's like 2 points, 1 point for each polygon. It's pretty simple, super basic thing. But we're going to see that all the algorithms, when we do them in processing, there is something. One thing that I'm going to show you before I forget, there's a chapter that it hasn't been merged already into the QGIS training manual. In case you want to learn QGIS, it's a very good reference. It's not the manual. One thing is the user manual that explains things. The training manual is more for like a workshop like that. It has exercises that you go progressively learning. And there's a big chapter with a lot of stuff about processing that basically goes through all the things that we're going to see here today, right? So I will find for you later. Like, I see that you're taking notes. Instead, if you don't want to take notes, then you can, I can just give you the URL and you can just find it, and that's an explanation of everything that we are going to do today, right? This is our first layer, and we're going to calculate centroids. So what do you think we can do to do the centroids? Most obvious thing is to go to our filter and type centroids and see what happens, right? Okay. First thing that you see is that there are, if you have the simplified interface, that might be different, right? But I'm using the advanced interface. But one of the things that you might see is that there are several different things that contain the word centroid. Some of them are not what we think. They're going to generate points along a line. Yeah, it uses the pixel centroid, but it's not exactly what we want. We want the centroid of a polygon. But there are 2 of them called polygon centroids that they look the same, right? It's the same name of the algorithm. The thing here is that, as I mentioned, processing is a consumer of different algorithms coming from different providers. We call them a provider. And in this case, there are 2 providers. One is QGIS itself, and the other one is Saga. They actually have the same algorithm, right? Sometimes the same algorithm has the same name, but there's something slightly different, in each one of them. But sometimes it's the same. This might be a little bit confusing, but it's actually not. You can have in your computer 2 softwares that do the same thing, right? Slightly different, but you can have 2 softwares that do the same thing. You can have Chrome and Firefox. Yeah, they're both, thanks to both web browsers, they're different, but they're the same thing. So in here is the same. This is a centralizing tool of all the analysis that QGIS support. So in this case, QGIS support 2 different things to do centroids. One is a purely QGIS algorithm. I mean, it's actually implemented in QGIS. It's the one we're going to use. And another one needs an additional software, which is Saga. We're going to use Saga later, but we need to configure it, so we're not going to open that one. We're going to use this one, the Vector Geometry Tools Polygon Centroid, right? This is the one that we're going to use. And to execute the algorithm, we just double-click on the name, right? Okay. And this is the main window of any algorithm, except for 2 or 3 algorithms that have a custom interface. All of the other algorithms, they look like this, exactly like that. You're going to see like name of the parameter, name of the parameter, name of the output, and then it's just like list of things that you need. There are no fancy interfaces with, no, it's just like that. Okay, and what way I'm going to do in the next exercises, I'm going to run a few algorithms that use the different types of inputs that we can have, that they're not massive, like 8, 10 different types of inputs that I can use, and then I'm going to discuss how the output works, etc. Right? So that's basically it. You're going to see 3 tabs in here. Parameters is the basic one. That's where you have to enter your data, right? The data that you want to process, the parameters to adjust the algorithm, right? Then the log. Not in this case. This is a normal algorithm that, it's just going to generate polygons. But some of the algorithms might give you more information about how the process was done. So in the log, they might add information. For instance, if we call the Saga algorithm, it's going to call Saga and then grab the output from Saga. So it's going to log all that output. Everything that Saga says is going to write it down. That way it's easy to find if there's a mistake, there's a problem with the data, Saga is not correctly installed, whatever, right? This is an important thing. If you start using QGIS and you have any problem, you just go to the mailing list or send a message to myself. It's better to use the mailing list, but if you go to the mailing list, don't say like, hey, it doesn't work. That's not helpful. This is 90% of the people doing that. Like, I have a terrible problem. Oh, I need this for tomorrow. It's not like that. Just provide more information. Like, I have tried to use this algorithm. This is the log. Then I can read the log and I can say, this is what's going on. Problem is that the software is broken, or it's your problem, or whatever, right? So if you want to give more information to someone that you want him to help you, then provide the information in the log. I will show you later another place where we can get the log, but remember that it's in here, right? Then we have the help tab. Unfortunately, most of the algorithms don't have help because it takes a while to write that, and the resources in the QGIS project for that are not great. So there's no help. If you like QGIS and you want to contribute, even if you don't do programming, you can contribute right in the help. I'll say it again a few times. So see if I can convince you. But it's a very good way of helping, actually, because we don't have a lot of help for that. Okay, so we go back to the parameters window. I'm not going to use the log or help tabs during this course, just going to focus on this one, right? So now let me explain to you what is going on here. We need just one input, the layer, right? We are going to calculate the centroids of a polygon, of a layer with polygons, right? So the only input that we need is the layer with the polygons. That's basically, we don't need any parameter to adjust it. It's just a centroid. There's nothing to adjust. Just that, okay. So we get one input. And the inputs, when you have an input of type vector, you're going to see a drop-down menu like this one, right? Which will display all the layers that you have in there. In this case, I just have one. So there's nothing more. But when we produce new layers, you're going to see more things. In this case, it's a polygon centroid, so you are only going to see the polygon layers. If you have raster layers or point layer, you're not going to see them. The list just shows polygon layers, right? In this case, I have one. That's it. Another thing that you can use is you can actually select a file. So if you click in this button, it will open the typical file selector. Okay, so you can calculate the polygon centroids of a layer that is not open. Actually, even if it's not open in QGIS, you can just click in it and it will just, and you search for it, and that's it, right? And finally, you're going to see this button in here, which is a button used to iterate, and this is a more advanced technique that we will see later. So by now, don't think about that. By now, the only thing that you have to know is that we're going to use a layer that is loaded. That's why I gave you this QGIS project. I have my layer called polygons in there, right? So I just extend it, and that's fine, right? Extend it, I select whatever, and that's it. So that's the input. I calculate, well, QGIS calculate the centroids, and then it generates an output, which is a point layer. This output layer is going to be an output layer. And whenever we have an output in processing, we're going to have this field in here where we have several options. One option is to just write the name of a file. I can type in here the name of a file, right? Or I can click in the button and select the file in the file selector. And the other option is to leave it empty. Don't do anything. And it says save to a temporary file, right? If I don't do anything, it's going to generate a file in a temporary folder, and when I close QGIS, it's going to delete it, right? In this course, I don't want to keep these files because I'm not interested in them. So I'm always going to use a save to temporary file. But if you want to keep those files, if you're doing like a real analysis and then there's a file that you want to give to someone, then you should enter the file path, right? Okay. So by now I'm going to leave that to temporary file. I'm going to use that, but remember that it's important because sometimes you save to temporary file, then you have here like 10 files with all your stuff. You save your project, then you close, and when you open your project, QGIS says, oh, I cannot find the files. Yeah, that's because they were deleted, they were temporary, right? So if now I click on run, it's going to take my polygons layer, calculate the centroids, and generate the temporary file. Yeah.
There's an option save to memory layer.
Yeah, another option save to memory layer. If you click in here, you're not going to go straight to that. Save to memory layer, it's actually a temporary layer, but it's not based on file. It's memory based. So just in case you are. So it is the same thing, but it's not file based. It's just a memory layer. Don't use that if you're going to generate something that is pretty big, right? I mean, in this case, I'm going to give it 2 points, but if you have like 10 million points, don't use a memory layer. Right? Okay, so yeah, just to show it so the other people see it, right? Save to memory layer, by the way, is not available in all the algorithms. Oh, for raster outputs, you can see that it's not available, right? So it's save to temporary file, and just cleans that, or save to a file, and it will open the file save file selector, and you select your file, right? We'll go back to this, don't worry. I'm going to use the save to temporary. We're going to run this algorithm again, so I can explain you some other tricks with that, because that's the important thing. So as I said, this is like very basic thing, but it's important to understand, right? All this stuff. I'm always looking at that part, not looking at this half. I'm gonna try to change a little bit. Okay, so click on run, and there we have it. Right? So we have a new layer that is called output layer. The name of the layer usually is the same name of the output as you see, but not always. It might change, but anyway. There it is, right? So that's it. That's how all the algorithms work. It's as simple as that. You have a window with parameters, you click on run, and it generates something. That's it. Now, if you put your mouse pointer over the output layer, actually, yep, that's it. That's the path. In this case, it's like, it's my user folder, update the local time processing, blah, 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 and that's the name, right? So that's the place where it's saved. Whoop, it went away. Well, I can actually see in there. The properties, you see, this is my temporary file with an ugly name. That's going to go away when I close QGIS, right? Because I said it should be to a temporary file. Okay. Thing that are interesting to mention about this, and this is like the very, very basic thing, but it confuses people a lot, so I'm going to go through this several times. First thing is coordinate reference system. I suppose that you are all familiar with coordinate reference systems, right? We're working with special data, so the coordinates, well, there must be a system that tells us what kind of coordinates they are. And why this layer has this coordinate system like EPSD 23030? Well, that's because that was the CRS, the coordinate reference system of the input layer. So there's no reprojection except for the algorithms that actually do reprojection, that we're going to see them. Except for that, all the other algorithms, they don't do any reprojection. So if you put a layer in whatever projection you have, the output is always going to be in that same projection, right? You understand that? So that's important to understand, right? What happens if some algorithms take several layers, right? It's like, there's like clipping or union, those things that I mentioned. Well, if they take several layers, it's going to read the CRS of the first one, and then it's going to assume that the other ones are in the same projection, right? And that's what it's going to do. If they are not in the same projection, then it's up to you to change that. But processing, it doesn't work at all with a projection. You have to prepare them, have your data in the projection that you want, right? And then use them, right? So in this case, my original data, it's in 23030. My canvas, it's actually on 23030. That's the thing that I'm seeing in there, right? And that's my output. One important thing to consider is that QGIS has on-the-fly reprojection. See, enable on-the-fly CRS transformation. If you click on this icon in here, right, you are going to see this. What does that mean? That means that if I have one layer of this place in Denmark that is in a whatever projection, and I take another layer with this same place in a different projection, QGIS is going to reproject them so they actually are one on top of the other because they represent the same place, right? QGIS is intelligent for that, right? It knows that there is in different projections, but it reprojects on the fly, so in the end they end up in the projection of the view, right? That means the two layers that one has coordinates like 20 degrees, whatever, and the other one is like whatever million meters, you know, you put them together, but they're still different, right? One is 20, the other one is several millions. That's QGIS that does that, not processing. So even if you see two layers, one on top of the other, they match, then for processing that doesn't mean that they match. They're separate, right? I don't know if you get the idea about that, right? So it's important to see that. Anyway, there's some check-in done for that. So if you open your Polygon Centroids, let me enable that. I will go to okay. So you see, if you enable that, I'll show you how to do that later. If you enable showing the projection, it's going to show this by the name of the layer, so you see that. And if you actually try to use two layers with different projection, it's going to warn you. It's going to, hey, those layers are, maybe you're seeing them one on top of the other, but they don't share the same projection. Are you sure that you want to use them as input, right? So it's going to check about that, but it's good that if you check yourself as well, right? So that means that this is the CRS EPSD 23030, and that's the one for the output, right? It's important to know that. Same for the input, goes for the output. Yep.
What happens if you open a shapefile without a projection?
If you open a shapefile with a projection, the resulting one will not have any projection, but it's recommended that you go in here and select set CRS and then you set the projection, right? So if there's no projection, then it's just going to copy whatever it's in here. So if there's nothing in here, there will be nothing in the output, right? But it's recommended that you can go there. I'll do it again. So you just right click on the layer and you select set CRS and that sets the CRS. You can select from a list, right? Or even write the definition manually, right? Any more questions? I'm going to go through this. Actually, there's one exercise that we're going to do with reprojections and things, so I want you to know about it. Okay, so you have generated that layer. If you go again to the name, to the properties of the layer, you see this is the file name, the temporary file name, and it's a shapefile, right? Okay, how does processing handles the different file formats? If you want a particular format, there are many formats that are supported. When you type on the file name, you just type the right extension. If I want a shapefile, I just be like myfile.hp, right? If I want a GeoJSON file, I just type myfile.geojson, right? And it's going to understand that extension and use it to define the file format. If you select save to a temporary file, then it's going to take the default formats, which are shape files for vector layers, TIFF files for raster layers, and DBF for tables, right? If you want a different format, then don't use this save to temporary file. I mean, if you want a different format, you just go and type your name, and this is what we're going to do now. Just type the name of the extension, name of the extension that you want to use. Actually, I'm going to generate a GeoJSON file, right? Anyone knows what a GeoJSON is? You're not familiar with GeoJSON? Why? You know what JSON is? Yeah? Well, GeoJSON, it's one format that is used to store geodata in a text file, actually. And if you have used some web stuff, it's a pretty common thing for JSON stands for JavaScript Object Notation, if I'm not wrong. So it's a JavaScript thing, it's a language that is used in web browsers, and GeoJSON is JSON but adapted to GeoStuff. So if you have used anything, kind of Google Maps or stuff like that, you know, online maps, it uses GeoJSON to move information, right? You know, actually, I think in OpenStreetMap, it uses GeoJSON for the vector tiles, and so, well, that's basically another format. So there are many different formats. It's not the best format, but it's pretty readable. We're going to see actually how it is. So let's generate one so you can see it. Let's go back to polygon centroids. And then now type a file. Let's type a file in here. I'm going to store it like in my centroids. GeoJSON. That's GeoJSON. Okay. You might know other file formats like DXF if you're used to CAD software or whatever, Spatialite, etc., etc. Right? Okay. One thing that you cannot do, in case you were wondering, one thing that you cannot do from processing is to put the output into a database. Right? I cannot put that directly into a PostGIS database. How many people here have used a PostGIS database? Okay. I'm seeing who are the smart guys or smart advanced students. Okay, I'll try to target my... Well, anyway, you cannot put data into a database. You just have to go to a file, right? So GeoJSON is a data file. So would you just enter whatever you want in here? You can use the button here to go to the menu, or just find a path in your computer. I'm just putting it in directly in the root of my hard drive. d:/centroids.geojson. Same thing. You see now if I put the mouse on top of it, that's it. It's actually in there. Let's open that file so you can see it actually. That's a GeoJSON, right? Basically a text file. So it's a feature collection. It's a collection of features. I have the CRS. This is the information about the CRS that is stored. As I said, it's pretty readable. It's human readable, right? It's not binary stuff that you can read. And then the features. There's a collection of all the features. There are two of them, 2 points, right? Feature with the properties, which are the same properties of the polygons. Well, we will see that in QGIS, right? And then another feature with another point, and this is the coordinate, blah, blah, blah. The coordinates in this CRS, right? Let's refer to that one. Right? So this is GeoJSON. In case you want to know more, just type GeoJSON in Google and look for it. That's a good thing to know. If you're going to be in the geo world, I guess you should know what a GeoJSON is, actually. Okay, go back to, let me close that. Go back to here, right? So you see there, it's simple, right? The window that we are using in here, it's rather simple, but with some tricky stuff, right? So you,
I have a question.
yeah, Centroids.wrong, okay, something like that. And this extension that he cannot understand is like, I don't understand what a wrong file is, so I do a shapefile, right? So it goes back to the default, right? The problem that Martin was having is that apparently if you select your file in here, let me show you, save to file, and I just select in here the GeoJSON. It's like Centroids 2 GeoJSON, right? Then the name it writes here is not GeoJSON, it's GeoJS. So for some reason it's taking out the 2 last letters. Okay, so that's like GeoJS, that's nothing. That's not a format. So you understand. So you just have to manually type in here ON. Okay, right. So that's a moldback. Okay, cool, good thing. Let me show you one thing, by the way. Something that doesn't work like that, instead of just saying, hey, Victor, this doesn't work, or just telling to your friend and saying, this software is terrible. You just go to the wonderful QGIS bug tracker. You just look on Google, QGIS bug tracker. And this is a place where we keep all the things that are actually not working. You see all the same to mine. Some people have been asking a lot of feature requests lately. Yeah, it seems that someone actually today has been adding a lot of processing stuff in there. So in here you can add bug reports or feature requests, whether you want to see something implemented in QGIS or something that doesn't work. And it's the best way to report a bug. You just sign in and you just fill a bug, right? So if you can do that, that would be great, because then we can just go. I can come here, see what the problems that people found, and I can fix them. If you just find something that doesn't work and you don't tell us, there's no way we can fix it. So if you want to contribute to the project, even if you don't do programming, you can write our help files, I say it again, or you can report bugs. That's pretty useful. Remember the QGIS bug tracker. In case you don't want to enter the full path, right? Let's say, like, my case was pretty easy. I was putting things into D, in the root of the D drive. But imagine that you're putting your stuff in D slash my data slash the course slash whatever. Instead of typing that all the time, you can do a little trick and you can define an output folder. And when you define the output folder, then you don't have to enter the full path, just the name. So I would do just like centroids.geojson, like that. And that goes to my folder. How to define the folder? I'm going to show you that. You go to the processing, options and configuration, right? And in here, there's the output folder, and in here you can type the folder. So it's going to add that automatically to everything that you type. If it's not an absolute path, if it's a relative path, it will make it relative to that folder that you enter in here. So here you can just click on there and type the folder. I never use this, actually, but you know. We're going to see this later in detail. So there are plenty of configuration that we can do, especially for the providers. We're going to see that, but I'm going to move now to another thing, so don't worry, right? Most of the things are pretty easy to understand what they do, right? But anyway, just make sure from processing, options and configuration, and you have some options in this menu that you can turn. One thing that you can turn on that is useful to have actually is the show layer CRS definition in selection boxes. I don't know if you have them turned on by default, but you can turn that on and you're going to see the CRS of everything that you're going to process. So that makes it easier to identify if two things have the same CRS or the CRS that is going to be used for the output files, right? Okay, so you get that this is the basic way that processing algorithms work. You know, we've done a very simple thing, just calculating points, but we've seen a couple of very important ideas, fundamental ideas about processing, how it deals with the CRS, how it deals with the output files, extensions, etc. So, you know, this is the things we're going to do, right? All these lessons are very atomic ones, like small ones. This is a small lesson and we're done. This first lesson is gone. Now we're going to open another project and we're going to do some other things, right? Okay. So we close this one. It's going to tell you if you want to actually, I left the mouse pointer like that. Let's see if it takes that away. It will tell you if you want to save the project. Don't save the project, they have temporary layers, so just take that away. And so you're going to see some more stuff that we're going to do with processing. And in this case, we're going to see some other types of input, right? As I said, there are like 8-10 different types of input, and we're going to go through several of them. We already know one of them is the vector input. We also have seen vector output. We're going to go through all of them. But as I said, it's just the basic interface is always the same, right? It's always this set of rows with values and the names of the values, right? So in this case, we have a table. Anyone knows how to open a table in QGIS? No? How to see the content? Well, you can open a table just as a vector file, right? Tables in QGIS are vector files with no geometry, right? So there's no difference. There's actually a vector layer. If you want to see the content of the table, of course, there are no geometry, so there's nothing being painted on the map. But if you want to see the content of the table, you just right-click on it. You select Open Attribute Table, right? This is what I mentioned before, that I guess you know it. Vector layers, they have an attribute table, and that's the reason why it's interesting to know this query languages to do things. Not actually in this case, might be, but well, it can be in this case actually, but depends on what you want to do. What we are trying to do is to turn this table into a layer, into a points layer, right? Anyone knows how to do that in pure QGIS? No, you've never done that? Okay. Well, one of the things that you can do in QGIS, it's when you open a layer, there are many different ways of putting a layer into QGIS. One of the ways is just open the table as a vector layer with no geometry. That's a table, no geometry, although there's the coordinates, but there's like no geometry stuff in here. Another way of opening that is if you go to layer and you got it, add the limited text layer, right? So you can open a file with a text columns with coordinates and convert that into a points layer. Right? We can do that with this layer, but there are things that, as I mentioned, you can do them in QGIS. You can also do them in pure QGIS, let's say, just like with using some core functionality, and then you can do them in processing, right? That might seem that it's redundant, it's repetitive, like having the same thing in different places, but it's not. Because when we have it here, that means that if it's in processing, we can then use the modeler and all the things that we're going to see that makes it more advanced, and it's better to automate stuff, right? You can use it on the console, in the Python console. And so in this case, we can create a new layer with this add delimited text layer, but we can also add it in here, right? So now I leave you 10 seconds or a minute. See who can find the algorithm to do that. It's like turn this into a layer using processing. So how we do that? And that's this kind of things like you have to look for it, right? So this is what I'm going through. We have started with setting up the framework, running the first algorithm, etc. I'm going to go through this. I'm going to skip some things, but this is basically the idea. So this is if I don't find them with the training manual, I will just give it to you. I will give it to Lynn so she can put it somewhere. But this is basically a set of exercises we're going through. This is what I use for the workshop. So I wrote this part of the training manual, and actually you can see that it explains more or less everything we're doing in a very nice way. It's like slowly it discusses all the stuff that I've been telling here to you, right? So I will just pass it to you. So for this next way to put that, so if you might be, yeah, that's it. So you say table, I'm going to use a table. So let's see what things deal with table. And I say like points layer from table. That sounds like what I want to do, right? I'm going to use a table and create a points layer, right? So as I said, it's the same thing as the similar thing to what I can use with the delimited text. In this case, I'm not working with a text file directly. It should be open in QGIS. It's already open, but it's a table, so I want to turn that into a points layer. So I can go to points layer from table. Okay, this looks a little bit more complicated, but it's the same. You see, parameters log help. The parameters just list input, the output, right? Things that are worth mentioning here. I told you when we have a vector layer, you're going to have the list, drop-down list of all the layers that are open. In this case, all the tables that are open, but it's still a layer. As a vector layer with no geometry. And the side you see the button, so we can just open some file instead of one of those. In this case, there's no button, right? Why is that? That's because we have these fields here, and this field refer to this one. So if the file is not open, there's no way that processing can know which fields are available. So when there's some field that is dependent on this one, you're not going to see the button. So in this case, you can only create point layer from a table if the table is open, not if the table is a file that is not open. That's one of the limitations, right? So I select the table in here. I just have this one, right? And now I select the field with the x coordinates, the field with the y coordinates, and I select them from the available fields. You see I have x core, y core, then I select in here. Okay, the x core, that's correct. And I change this one to y core, right? So those are the points that I'm going to use, right? So see, I'm seeing the different types of input. There's a table input, a field input, and this is a different type, a CRS input, right? So I cannot write in here, but I can click on this one, and that takes me to the CRS selector, right? Well, actually, the coordinates are on EPSD4326, the default one, which is WGS84. Okay, so there's no you've seen here WGS84, EPSD4326. Okay, so there's no need to change that, but in case your points have a different CRS, in this case this is an exception. What I said, like the output, the CRS of the output is the CRS of the input, but in this case the input doesn't have any CRS because it's a table. So I have to provide that information, right? And it's going to use it to You know, there are some algorithms that don't follow that. You know, there's some exception, but if there's an input, the output should be, it's an input and it has a CRS, it's a layer, it should have the output in the same CRS, right? So you select whatever you want from here, and it will just show up on there, right? So that's it. That's basically what I need to know, right? There's nothing more that I need to know. Just click on run, and it will generate my points layer from that table. Right? I don't know if you've seen what I've done. Maybe it generates, but it doesn't show up. Maybe because it's not focused on that. So you just right click on it and select zoom to layers extend. Okay. In case it shows there but not in here, that's because it was not centered. The view was not centered on the layer. So you just click on up layer, zoom to layer extend, and you just go to it, right? Yeah. These things that we're doing now, they're not terribly useful, right? Just calculating a centroid of two ugly polygons or creating this. Later we're going to do more useful things. We're going to move into the hydrology. We're going to do like actual analysis. But it's important to go through these very simple steps with processing so you understand it well, because otherwise you're not going to understand all these little details about the output format, the output CRS, different kinds of input, etc. Right? The idea is that in the end you're going to be able to understand all the algorithms. So if one day you want to do whatever and you know an algorithm, you just can go there and use it because you understand the interface. That's my idea about this, right? Actually, we can create a special indices for layers, and I'm going to show you how to do that.
Actually, we know what spatial indexing are. The LAX files we created, those were spatial indexing files that accelerated spatial access in the LiDAR exercise. I think yesterday we did that.
Okay. So you've done all
that.
They all know. Okay. Well, it's going to show you some things about this. When you go, I'm going to do it slowly again. You right-click on the layer, on a vector layer, and you just go to properties in here. You can know a lot of things about the layer in here. You go to metadata. You can know a couple of things. You know, there's plenty of things to configure. The style. I'm not going to get into all that. But you have a button here to create a special index, right? So what is a special index, basically, apart from what you saw yesterday with Martin? Okay, imagine that, let me show it easier to you. Well, yeah, imagine that now you have what is an index? You all know what is an index, right? If I tell you, like, my name is Victor Olaya, so find my number in the telephone guide. What will you do? You just read every number until you find my one? No, you just like Olaya, that's letter O, so the order, you just go to O, and you just read what, 10 numbers, and then in the end you end up knowing my number, right? So now imagine that you have something like, let me open something for you. Yeah, that one for instance. That might be useful, right? Oops, not working. Let's see. Okay, that's it. You see all those points, right? There's not a lot of points. Like if you were working with LiDAR data, right? Before with Martin, you probably saw more. But if I say like, okay, here's my mouse pointer, right? I don't know if you can see it, it's there. And I say like, find the 10 points that are closer to that point. How will you do that? Well, the obvious thing is that you just measure all the distances, right? And then you get like, there are like 5,000 points. You measure from each point to here, then you get 5,000 distances, you order them, and you just take the 10 smallest one, right? Well, that's pretty stupid. I can make a circle in there that contains, 20, 30, and I can discard the other ones, so I don't have to measure all that, and I just do that, right? Well, this seems to be very easy to do, but it's not easy at all, right? To implement that in a computer, it's easy when you think about it, like we have a bunch of them, and then do that. But when you do that in a computer, it's not so difficult. So that's basically the idea of an index, that you don't have to go through all the things to get one. Like, which is the closest point to that one? You don't have to measure all of them. You just get a small subset, and then you just do the measurements, just 5, 10 measurements instead of 5,000 or 5 million, right? So that's the idea of a spatial index, and it's very important, right? It's not easy to implement, as I said. It's not so obvious. There are many different ways of indexing spatial data. But when you're going to do some operation that involves a lot of calculation, for instance, interpolation, we're going to interpolate the layer, right? So this is the layer that shows elevation, right? Okay, so let me zoom into that. So when we do the interpolation, we try to put a value in every place in the space, right? Let's say in here. What is the elevation in here, right? So remember what I told you about spatial correlation, yeah? The things that are closer are more similar, right? So if I'm here, probably the elevation is going to be similar to this point, right? Not similar to that, right? So I have to find the closest points. And to do that, if I don't have any spatial index, I have to measure everything. And that wastes a lot of time. So when you have a layer, a vector layer, and you're going to do things that actually involve this kind of computational geometry, do a spatial indexing. Just go here, and create a spatial index, right? Because it's going to make things go much faster. In the case of lighter data is so big that you always need that, so that's probably the reason why this lax file, you always have a lax file. In the shape files, you always have a SHX file, but in other data, you might not have that, right? So make sure that you index your data, because you're going to save a lot of time. Otherwise, it's really slow, right? It's just like looking at a telephone number that is not a telephone guide that is not ordered. It makes no sense, right? Trying to find a telephone on a guide that is not ordered. So the same with points. This is super basic thing, but most of the people don't know it. So I'm glad that I told you, right? Remember, operations that are geometrically intense, like that they do a lot of computation and calculation, create a spatial index, right? There's no way of creating spatial indexes in processing. You have to do that before, right? What is the you get the idea, right, of this, like, going faster. How can we do that on raster layers? You know what is the equivalent of that in a raster layer? Similar thing. So to speed things up. Anyone heard of a pyramid? Yeah. Okay. You know how to create pyramids in QGIS? No? I'll show you then later. Okay. The idea of the pyramid is that I'm going to show you. It's like, I'm pretty messy when I start improvising, but if I say something that you are not interested in, just stop me, right? But I think this is more important actually than going into the processing itself. But let me open some data for you, actually, and so I can show it to you. Then I will just try to send in some links with this information, because this is pretty important. This is sleeping. Okay, open. Yeah, it's not that bad. Okay. You don't have to open that. This is the de-elevation model that we are later going to use for hydrology. But imagine that this is actually 25 meters. It's not so detailed. But imagine that this is a 1 meter one, right? That means it has 25 times more points and 25 more points. So that's takes a lot more data actually. So this is a layer with a lot of points, right? And you have your screen, a normal screen, like, I don't know the resolution of this projector, but it might do like 124 by 768, which is the normal thing. So that says like you have in total in this little part might be, I don't know, a little bit like 500,000 points, right? 500,000 pixels, right? But if your layer is very detailed, the original layer might have more. When you take a picture with your camera, when it says 12 megapixels, I mean 12 million pixels, right? So that means that if I want to paint this thing in this tiny part with only users like 1,000, 100,000 or 500,000, I have to take like this 100 million pixels or 12 million pixels, use all of them, calculate things, and then generate this image, right? So that's basically, I'm taking something that is huge, process all that, and I get something that is small. So in a pyramid, what I do is like, I do that in advance. I do that at home. Okay, so I have my very detailed layer, then I have a layer that has less detail, less detail, and I create a pyramid. So if I need to paint it at this scale, I don't have to go to the big one, compute all that, and create the smaller one. It's already created. So I compute things in advance, right? So then when I do the zoom in and out, right? Okay, now this is the big image, but when I go out of here, it doesn't take the big image and makes it small, which is very intensive. It takes a lot of computing power. It already has the image prepared, right? So it creates like a pyramid, right? How to create that in QGIS? Once again, you go to the properties in here, properties of the layer, and there's an entry called pyramids, right? You see, in this case, my image originally has 601 multiplied by 410. So here it proposes having this auto resolution, like half the detail, then half of that half, then half again. So in the end, I'm going to have that big layers, not that big in this case, but reduced to this 75 by 51, which is a small one. So when I paint it in smaller size, I don't have to go to the big one and rescale it. I just go to that one, right? And I see that in my case, my image has one pyramid calculated, but not the other ones, right? So if I want to calculate them, what I do is just create them in here. I just select whatever I want to do. Let me know. I don't do this often, actually. How to select that? I should be able. Oh, you just can select that one, maybe. Whatever. There are some formats, like the TIFF format, that you can put the pyramid inside the file. So one file is the file and the pyramid. Some other, this is because of that. In this case, this is an ASCII file, so it's a text file actually. It cannot hold the image, so you have to use this overview format external. So it creates additional files. So instead of one file, you have several files with the pyramids. Well, just click on build pyramids and it will build them, right? So it's not that interesting anyway. Well, so that's basically the idea that I want you to know. In case you're dealing with big image, if you've seen, I'm sure that you've gone, you use this kind of Google Maps or something like that, they have different scales. So you have the big image that you see all the earth, and then you go zoom, 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 and then in the end you can see people and cars and things, right? Imagine to compute that image that just fits into your screen, if you have to take all the earth and create that each time, that's ridiculous. It will take years. So Google did that in advance for you, right? So when you ask for the image just of the whole earth, it just gives you the whole earth, not takes everything and makes it smaller, right? Okay, let's go back to processing. That was just my processing. We're actually not going to do any exercises about that with processing, but I want you to know that. Say that you have a layer like that, right? 1 pixel, just 1 pixel, right? Value of, 1 pixel, that might not be a good idea. Well, I went for like that, right? Okay. And the same as I said, layers, they have to match, right? What I mean, the same CRS, right? When you're combining raster layers, it's the same thing. They should match as well, right? They should have the same CRS, but also the same structure. That means that if I have a layer that is actually the same part of the world, but it's like that, when I put it on top of this one, it's the same thing, but each of these pixels doesn't match the other, right? So what you have to do is this resampling. That is, taking this and changing that into something that is like that, right? So I do some statistics. Okay, I get this. What is the value in here? And I put the value in here, in here, in here, right? There are different ways of doing that statistic. Different ways of moving from one grid to a different grid, right? But there's a big difference. And the main difference in all those things that you see here, right, is that if you use the average Gauss, cubic mode, whatever, you might have values that are not in the original layer. That means that if I have this, 2, 1, 2, for instance, right? So again, this one, I'm going to have probably the value of 1, right? So this is in the middle between 1 and 2. I might have 1.5, right? 1.5, right? And then here I have 2. Yeah, makes sense, right? But if this is an elevation value, that's fine. 1 meter here, 2 here, it's something like that, if you see like a profile. So in the middle is 1.5, right? But if this means like 1 is soil type A, and 2 is a code for soil type B, what does 1.5 mean? Nothing. Okay, so if you have any layer that has categories or values, then you cannot use that, right? Or let's say that this is the number of persons in this block, and this is the number of persons in this block, right? So can I put 1.5? Doesn't make sense, right? I have 3 people in this, and now I have 4.5 people in this. Doesn't make sense. So you have to take care of knowing the variable that you're using, right? If it's a continuous variable, use any of the other ones. Average, cows, there are differences, but you know, it's fine, whatever you use. But if your layer has something like that, like a counting of number, whatever, like categories, then the only one that you can use, it's nearest neighbor, right?
Mode, that would apply also.
Yeah, mode that would apply also. That's true. Yeah, haven't never seen the mode. I don't know what the known is actually.
Mode is.
Yeah, the known. This one called known is just like that's. Known might be like the known might be like nearest neighbor. I don't know what non means. Yeah, but the mode that might do. Yeah, actually. Yeah, and it's anything that doesn't make appear extra values, it's fine, right? So you see the average. You know, this is what I'm doing here. It's not a good idea for these categories, right? So just stick to nearest neighbor. Nearest neighbor, it's one thing that if you use it for an image, something like, you know, for when you visualize this, it's not so smooth. So it's not like kriging. It's not smooth and lovely. It's, you know, there are sharp edges. Like in here, it will do like maybe 1, and he was like 1, 2. So it's like, it's not a transition from there. So it's like, there's a block. It uses only the other values, so there's a big difference. It doesn't make it look smooth, right? But in this case, it's better. I mean, it keeps the data. It's not nice, but it keeps the data, right? Okay. Okay, let's go back to processing. Okay. So in your data folder, there should be a CRS folder, right? So now we're going to see more about this CRS thing, and you know, it's the final one, so you end up understanding correctly what CRSs are managed by processing. Right? So on the CRS, you're going to find a project called CRS.QGIS. You open it. Everyone, open that. So you're going to have basically the same points. They're the same points that we generated with our table to point conversion, right? You have 2 layers. One is called 20330. One is called 4326. So basically, we have the same points in different projections, right? If you turn this off, you see that the other one is underneath. So they're exactly the same, right? They're exactly the same thing, and they appear in the same area, but they're not. They don't have the same data, and this is what we are trying to see. If we just click on the information for this layer, you see it's 23030. That's the CRS. It's the same as the name, right? If you do the same thing with that, no, that was not what I wanted to do. You see that this is EPSG for 326, right? And how are we going to see that the coordinates are different? Because if you open the attribute table, you see there are no coordinates. There's some, you know, some number, string, and ID. There are no coordinates in here. In the other case, when we created the layer from the table, then the attribute table contains the table itself, including the coordinates, right? But not in this case. We have points, no coordinate. So what we are going to do is to add the coordinates, right? We're going to add the coordinates. So we're going to add new columns in here, right? That contain the coordinates of each of the points, right? So for this point, in the row, we're going to add 2 new fields with the coordinates. And we're going to do the same thing with the 2 layers, right? And then we're going to compare, okay? So I leave you 2 or 3 minutes. You try to find out how to do that. If you enter a polygon layer, it will add the perimeter, the area of the polygon, right? And if you enter a points layer, it's going to add the coordinates, right? 2 new columns with the coordinates. So the output, the columns that it's going to add depend on the kind of output that it's going to calculate, right? Yeah. So in this case, I'm going to use this for a point layer, and I'm going to add the coordinate, and I just have to select the layer. That's simple. That's clear. But then there's another fill. Why is this moving? There's some people going and walking. It's like whatever. They calculate using different CRSs, and if you extend that drop-down menu, you see you have different ones. Like you can use the layer CRS, which is like the layer that the CRS that the layer uses. The project CRS, that'll be that one, right? Or the ellipsoid. We're not going to use that, right? So we're going to use the layer CRS, because what I want to do is to calculate the same thing with the two CRS, with the 2 layers, right? And using the same layer CRS, right? So I enter the layer CRS for the 4326, right? Calculate and run. It generates a new layer, the output layer. Now, if I open the attribute table, you see there are 2 new columns, x coordinate, y coordinate in here, right? So this is in the 4326, right? 4326, it's a CRS that uses geographical coordinate. That means the x coordinate, okay, that's 5 degrees, right? It's not 5 meters, it's 5 degrees, okay? Longitude, or minus 5 degrees longitude. Yeah. Okay, so that was basically the idea. I want you to see that here in this case, the CRS are different. They appear on the same place, but actually the coordinates that are being used underneath, they're different. Like what I want to say that later we'll go to do some processing, but if I say like, let's do a buffer, a 10 meters buffer, right? So my view, I can change that, right? I can change my view. Let me set. So see, my view is in 23030. Let me close all this. Thanks. Okay. So you see my coordinates in here are in meters, right? Because this system uses meters, right? So I can say like, oh, let's calculate a buffer, a 5 meter buffer, right? So I go to my layer in here, this one, 4326, and it's like, let's calculate a buffer of 5 meters. I go buffer. I can look for my buffer in here, and there's going to be a field saying distance, and I enter 5, right? I'm seeing this in meters in here, but my layer is in 4326. That means it's degrees. So I'm doing a 5 degrees buffer, which actually doesn't mean anything because it's geographical coordinates, right? So you have to take that into account, that what you see here, what you see in here, the units that you use in here, those might not be the units of the layer. And processing doesn't care about this. It cares about the data, okay? If this layer, when it's like, give me your coordinates, and the coordinates are like that, so well, not that one, well, whatever, I think this one was in 4326. No, that one. So when processing is like, I'm going to calculate a buffer, give me the center coordinate of the buffer, and it asks that layer, and it gives that this value, even if in here I see that, this is the value that it's going to use. And this value is not meters, and the coordinates are not in meters. Okay, so never forget that the important thing is the CRS declared by the layer, not the one that you use in here, not the one that you use in here or there, right? So don't forget about that. You can do things like, if you have a polygon layer, right? If let's go back to one of the other examples, just to finish this, to the one that we saw at the beginning, the first algorithm. Okay, see 23030 in here. You see geometry columns. If I enter my polygons, right? If I enter my polygons in here, it's going to calculate the area and the perimeter of right? The area. But what happens if I select layer CRS, and even although this isn't here in 23030, in here I have the EPSD 4326, then the area would be like square degrees. That makes no sense at all, right? So if I have a layer that is in EPSD 4326 and I'm going to calculate something like an area, I cannot do it on the layer CRS. Even if I'm showing it in here with a different thing and units that make sense, square meters. No, I have to change in here and use the project CRS, right? So it will reproject to something that is actually, plane coordinates, and then calculate the area and all that, right? So it's important not to lose that, especially in the difference between projected and geographical coordinates, right? I don't know if you get the idea. It might be complex, but this is not a thing about processing or about QGIS. It's basic GIS stuff, right? The projections are always tricky, You cannot do a buffer in geographical coordinates, right? You cannot calculate distances on that because distances are different. It's a different kind of geometry, actually, right? So it's not non-planar geometry, right?